So it's specifically, so holism is essentially a good word for everything. So it is designed for manufacture. So going back to the example of the Raptor motor, they were designing for performance, and then there was a secondary emergent advantage in the design for manufacture. So they wanted to prove the concept and say, okay, this is how the system works. And then they improved on it by bringing in those principles of design for manufacture. So it's this and this, not a this or this. So it's an and instead of an or. So it is designed for manufacturing and designed for economics and designed for performance. All of these things go together. And that's actually the power of holism, is that you're taking all of these into consideration. And going back to the example that we were using of the EV tolls, is that one of the, so you have to look at the entire technology as having multiple dimensions, just like people. We have thoughts and we have emotions and we have a physical body. It's the same thing, is that, for technology, we've got the economics, we have its operational fit. And we also have how is it made, and what is the actual design and function. So when you're making something for manufacturing, you're making it for ease and cost reduction of manufacture. So you're saying, okay, how do we best how do we best design this specifically for that? For performance, so when you're adding all these elements in, which what I'm trying to say with this entire concept is, this entire mindset is that you add all of these dimensions in simultaneously. And it's not as daunting as it sounds. A lot of it is that you really just kind of you have to step back, and this is why I go back to the energy nucleus issue, is that you have to really understand it from its most fundamental first principles, and then everything else becomes emergent once you understand the system. So you basically, what you're doing is you're calibrating everything specifically for the change that you want to make. Some of them, like when we went from like prop plane fighter jets to jet fighter jets, there wasn't much of a change because you essentially were just kind of one-to-one swapping. You could essentially use the same fuel or something equivalent. So there wasn't a necessity for holism per se. There was just, you can get away with evolving it. But when you're trying to do something that's as drastic as electrifying aircraft, the storage mediums being so different, that difference requires that understanding of the uniqueness. And what you're doing with this is essentially piling each dimension on itself, and all of it becomes an emergence. So, how you can get away with doing this as an organization, and I see Albert's question about the stage of development, concept, engineering, drawing, tested components, is this is how you can actually be sort of where we are. So, we've been kind of in this space where we've brought the architecture to about a TRL4. We've done a lot of laboratory testing. We've done a lot of laboratory testing, a lot of prior research. We've done a lot of analog testing, so proof of principle at scale, to basically essentially prove and then model the system. And all of that has become an iterative process. But that's how you can get away with having very lean, very low capex while you're understanding this changing of the paradigm. And then what happens is that now I can enter into the equation asking for funding for for full development of the power propulsion system, the airframe itself, all of those individual components now have their place in the development life cycle. But now that we've understood it, as these have an intention to go into this system, this is where you end up getting these gains that bring you to more of a competitive space. So I don't know if that particularly answers your question directly. I know you were asking more about design for manufacturing, but I think the core statement I'm trying to make is that it's all. It is literally, if it's not just designed for manufacturing. It's not just designed for performance. It's not just designed for economics. It's all of the above. Each one of those components has to be understood as its particular dimensions overlap. And once you do it, when you do it more mentally and you do it in like a high speed of evolution of the system itself, you don't waste a lot of money trying to build components that are hopefully going to, be the holy grail of component. Because if you actually do the modeling, you see that if I were to make the most ridiculously 100% efficient, super high power density proton exchange membrane fuel cell and electric motor, if there's no real overlap of usage of energy, you really only get these first order gains. I mean, it only really appears in terms of maybe 100 miles, maybe 200 mile gain for a specific aircraft's size. But when you start going into this overlapping space, is when you literally start seeing these multiplicative step change gains where you start going from like 500 to thousands of miles. So
So it does answer the question.